Hello, it's Unit 9 review. I'm so excited. Can you tell? Are you excited? All right, number one. The graph of the function f of x equals square root of x is shown below. Describe the transformations that would happen to the graph if the new function was this. All right, cool. First thing I see is that the vertex changes and it will now be -2, -4. So let's graph that first. Cool. All right. Next thing I see is that we have a vertical flip. I really could just be writing this down because that's what I asked for, but I'm just being extra. So vertical flip means it flips over the x-axis, so to speak. So I'm gonna do this. I'm gonna make my life so much easier. And I'm actually gonna just take this graph. You see what I'm doing? Do you see? Do you see? I flipped it. You see? Hold on, let me get rid of this because y'all ain't seeing what I'm seeing. I flipped it over the x-axis, and now I'm gonna go -2, -4, because I'm a G. You're welcome. Putting you on game. I stay trying to put y'all on game. Okay. I said that with so much confidence. Let me, because it's late and I'm be making, I'll be making mistakes. Let me just double check that. Home, discard my changes. Let us start anew. All right, so we've got the square root. No, we've got negative square root of x. Was it -2? I feel like it was +2, and then it was -4. Fantastic. Just making sure I didn't screw that up. Okay, great. So again, we had a vertical flip. We also can say that it's a reflection over the x-axis. Remember when we did that first? Kind of. And then it went, it's a horizontal shift, if you will. And we went left 2, and then we had a vertical shift of down 4. Okay, that was a lot. Sorry, I was being a little extra. But y'all are used to that by now. Number 2. Number 3. What value of x makes this true? Show all steps to solve. So I'm going to jump right into it, and I'm going to do the cube root of 2x plus 12, and then put that equal to 4. The reason I did the cube root is because of this exponent of 1/3. I told you, whatever the denominator is, that's the root. And since the numerator is just 1, we could raise this to the first power, but that would be foolish because it doesn't do anything. All right, so now I'm going to raise both sides to the third power in order to cancel out the cube roots. Voila. 4 to the third power, if I'm not mistaken, is 64. Am I right? I am. Okay, and now I'm going to just solve this two-step equation. Y'all should know how to do that. Well, most of you should know how to do that, bless your hearts. Hmm. All right, and so we get 26, and of course, you know we're about to check our work. Of course you know we're about to check that work. So we're going to plug it back in. 2 times 26 plus 12, and that's going to be 4. All right. Oh, it did say to the 1/3 power. It's the same thing. I'm not changing it. I'm tired. 56, 52. I know how to multiply. And then the cube root of 52 plus 12 is 64. And the cube root of 64 is 4. We good. Try number 4. All right. Making sure that was the same problem. Number 5. What's the solution to this? That's a great question. All right, I'll write it over here because I'm a left to right kind of gal, and it feels weird starting otherwise. All right, +2 equals 8. All right, cool. First, let's get rid of this +2 because you are all up in the way. Ain't nobody trying to do what you like that. Okay, cool. Now we're going to raise both sides to the third power to get rid of that cube root. So now we've eliminated, what do you call it? Canceled out. Woo, canceled out the cube root. 6 to the third power, I'm pretty sure it's 216. I'm willing to bet money on that. And we're going to add 2 to both sides, and that'll give us 218. Boom! Check your work. Plug it back in. Make sure it's right. I keep making these so long. Yup. All right, moving on. Try number 6. Y'all should actually try these. Number 7, the table below includes values, blah, blah, blah. All right, it says square. This is important, square root function, and we need to write a function that's represented by the table. So, since we know it's a square root function, it's not a different kind of root, we can start off by trying to take the square root of these numbers and see if we can find some kind of pattern, because I'm not sure if there's a square root regression on your calculator. It wasn't on mine. You want to go look? Let's go look. You're on this journey with me. Discard my changes. Where would it be? This seems like a lot of work. No, I forgot how to do it. I remember we have to like make the table and all that. That's a lot of work. All right, anyways. So I'm just going to take the square root of all the x values and we're just going to go from there. Okay. Square root of 1 is 1. Square root of 2 is something. So let's figure that out. 1.41. Just going to round it. And then the square root of 3. 1.73. And square root of 4 is just 2. All right, let's see if we can find any like connections here. So we know that this one's going to have to equal 0.25. This one's going to have to equal 0.35. This one's going to have to equal 0.43. This one's going to have to equal 0.5. Now, I don't know about these two, but I can see clearly now the rain is gone. That 1 divided by 4 is zero point 0.5. 2 divided by 4 is 0.5. Did I say that right? I wrote it down right. Let's see if these other two work. So I'm going to take this guy divided by 4, and I get 0.35. Oh, snap. I'm going to take this guy divided by 4. I get 0.43. Oh, snap. That's what we needed. So obviously dividing by 0.4, dividing by 4 is the right answer. So first, we're going to take the square root of x, and then we're going to divide it by 4. Voila. Good luck. Try number 8. Number 9, in blue. Graph the inverse function of the quadratic function when x is greater than 0. So when x is greater than 0, we're dealing with this part. So just keep that in mind. All right. So to graph an inverse, I told you this. I don't know if you was listening, but I said it. And we did it together in the notes and everything. When you're graphing an inverse, you can just reflect it over the line y equals x. That's how inverses work. I'm gonna write this down. You don't need to write this down unless you just really want to know. Reflection over y equals x means that the x and the y is going to switch. If y'all don't remember that from geometry, that's definitely something we did when we did transformations. So that's why when we do inverses, we switch the x's and the y's. So with that in mind, this point was 0, 2, so this point's going to be 2, 0. This point is, 1, 3. This one's going to be 3, 1. And this looks like it was 2, 6, so this one's going to be 6, 2. And I think that's the last one I see that actually has like a whole number point. So there you go. And you see, it makes a nice little reflection. It's beautiful. It's beautiful. Go ahead and try number 10. All right, now we got this. What's the value of x? So we're solving. I'm just gonna start from here because it's already on the left, and y'all know I like to write left to right, like I have said. If you were listening, not that it matters. All right, so we're left with this equals 4. That's just so big. Keep doing it. All right, now we're gonna square both sides to get rid of the square root. Okay. Excuse me, and that's x minus 5 equals 16. Phantasmic. Then we're gonna subtract 5 from both sides. And ugh, I hate when this happens. I don't know why it bugs me to have a negative x, but it just does. And then we're just gonna divide both sides by -1. Such a weird thing to be upset by. Then again, it is. It is me. All right, and check your work because paranoia could save your life one day. Could also be detrimental, but you know what I'm saying. Just saying it could save your grade. All right, so 4 square root of 5 minus -11 equals 16. Again, what the spaciousness. Yeah. All right, so that's going to be 4 square root of 16 equals 16. Square root of 16 is just 4. So yeah, we're in good shape. Looks good. Go ahead and try 12. 13. What are the coordinates of the vertex? Um, okay, look. If you can't tell what the vertex is by looking at it, I'm not gonna laugh at you in your face. I'm not gonna do that. But just graph it on your calculator and just look at it, okay? But anyway, this -5 means that the x value is 5. There's nothing over here, so that's just gonna be 0. That 3 in the front just tells you if it's stretched or not, but it doesn't tell you if it's shifted left or right, up or down, or nothing like that. Try number 14. Number 15. Okay, all right, sorry. So we're here. We need the, okay, so this is the inverse. Remember when I said, hold on, let me go back because y'all know y'all memory be slipping. Not as bad as mine, but still. When you do inverses, you switch the x and the y. Okay, so we're gonna do that for these. And the first time I taught y'all this, y'all were like, what's happening? What do you mean switch the x and the y? My brain is gonna implode. So we're doing it again. Hopefully it helps this time. I'm struggling. So in order to switch the x and the y, I'm first going to change this to a y, okay? Then I'm going to switch the x and the y. So I'm going to put the x where the y used to be, and I'm going to put the y where the x used to be. Nothing else changes. And then now you're going to get y by itself. So I'm going to add 10, add 10. So that'll be x plus 10 equals cube root of y minus 6. Now I'm going to cube both sides. Ew. Oh wait, I don't have to PEMDAS. I mean, I don't have to FOIL it out because that would have been nasty. X plus 10 cubed equals y minus 6, and then we're just gonna add 6 to, not like that though. I'll put it over here because those parentheses are keeping it out. Equals y. All right, cool. So F inverse equals x plus 10 cubed plus 6. Voila. Oh, so basically you can see like the opposite happened. Math magic. Try number 16. 17, we're gonna simplify. I'm gonna be real honest with y'all. I'm not writing all this out. Okay, because look, it's 11 y's. I have to write y times y times. I'm not doing all that. That's too much. So let me try to simplify this for you. Well, let me try to make the process simpler so we can simplify. Um, okay, I want you to think. I want you to use your brain and your notes. Use the list of all the perfect squares. I forgot what page it's on. What is the biggest perfect square we can divide 128 by? It's 64. So 64 times 2 equals 128. So we're going to try to break these down into the biggest perfect square we can, and then whatever the other factor is. All right. Now for the x to the fourth power is a perfect square. It is. Um, it is. And then y to the 11th power is not because it's an odd number. So I'm going to do y to the 10th and then y to the first. Okay. Don't forget when you multiply, you just add. the exponent. All right, so now this, this, and this are perfect. You know, let me use different colors because I'm just that brand of extra sometimes. Okay, so there you go. We're going to start with the 64. The square root of 64 is 8. The square root of x to the fourth power is x squared. Why? Because x times x times x times x. If you took the square root, you see you got two pairs of doubles, so that's x squared. Remember, every time you take out a double, it becomes a single. All of that. If you forgot, go back and refresh yourself. Don't be a victim. Be like, I can't remember anything. Well, then go back and study. Sorry, that got personal. All right, and then for this one, it's the same thing. There are 5 doubles if you have 10 Ys. You know what I'm saying? Be smart. And if you can't be smart, go back and look at your notes until you can't be smart. That's what I used to do. Because I'm not always the sharpest tool in the shed, and that's okay. All right, there you go. Number 18, give it a shot. Number 19, simplify this one. All right, there's a cube root, so this time we need groups of 3. I'll be honest, though, it don't take all that because 8 is already a perfect square. P to the third is already a perfect square. I'm sorry, perfect cube, tripping. So the cube root of 8 is 2, not 3. Get your life. The cube root of p to the third power is just p. Done. Go ahead and try number 20. 21, what's the quotient? I'm going to use synthetic division because I feel like it's a tool that I can use. Why wouldn't I use it? Don't make the mistake that I made last time. Please don't forget the 0 at the end. So since this ends with 7x, we have to add a plus 0. So that's going to be 1x to the fourth, 5x to the third, negative 3x squared, 7x, and 0. You have to include the constant. All of them have to be included. All right, drop down to 1. 1 times negative 2 is negative 2. Add those up, we get 3. 3 times negative 2 is negative 6. Add those up, we get negative 9. Negative 9 times negative 2 is positive 18. Add those up, we get 25. 25 times negative 2 is negative 50. Add those up, we get negative 50. All right, don't forget, this is your remainder. This is your constant. This is your x. This is your x squared. This is your x to the third power. So your final answer would be x to the third, plus 3x squared minus 9x plus 25 minus 50 over, what was it? X plus 2. Done. All right, go ahead and try number 22. Number 23. Height of a rectangular prism is given and the volume is given. Write the base area. So volume equals base area times height. So in order to figure out the base area, you'd have to do the volume divided by the height. So basically, it's just a division problem. It's just a division problem, excuse me. I'm using long division just because you could probably use some practice with that. So here we go, even though it takes longer and it takes up more space, practice helps. And then we got x plus 3. All right, I'm going to change this to black because like Amy Winehouse, I go back to black. Don't quote me on that. All right. Oh, sorry, that is not. There we go. All right, so we need to multiply by x squared because x squared times x will give you x to the third, and that's what we want. X squared times this is just going to give you 3x squared. Once we get here, you subtract. All right, that's going to give us, that's going to cancel out. And then this will be what? Positive 1x squared. And then we're going to drop down the 5x. Okay, I'm going to get rid of these because they are very much in the way. So now we're going to multiply by 4x. And this is positive 4x, so put a plus. And that's because 4x times x is going to get what? Girl, where I got the 4 from? I was looking at the one underneath it. Just x. So we're going to multiply x times x to get x squared, x times 3 to get 3x. Both of those came out positive, and we're going to change the sign, That's going to cancel that out, which is exactly what we want to do. And that's going to leave us with 2x. Drop down to 6, plus 6, excuse me. And last but not least, we're going to multiply by, it looks like 2. Don't forget that was positive. So by 2, so 2 times x is 2x. 2 times 3 is 6. Both came out positive. We're going to subtract by changing the signs of both of those. That's going to zero out. And oh, that zeroes out too. We love it when that happens. So my final answer is x squared plus x plus 2. Go ahead and try number 24. All right, at this point, if you are not in honors, you can go ahead and stop the video. Honors, here we go. So we're going to solve this, sorry, by squaring both sides to get rid of that square root. Now we have a quadratic. Yay. Okay, so that'll leave us with 0 equals p squared minus p minus 2. Is that factorable? I really hope so. Yeah, oops. So p minus 2 times p plus 1. That's, how do you say p but write x? All right, so that means p equals 2. That means p equals negative 1. All right, let's double check to make sure both of these are viable solutions. So the square root of 2 plus 2 equals 2. Square root of 4 equals 2. The square root of 4 is just 2. Yep, this one's good. Okay, let's check the second one. The square root of negative 1 plus 2 equals negative 1. Square root of 1 equals negative 1. Square root of 1 is just 1. That does not equal negative 1, however. So this is not, that is an extraneous solution. That's not going to work. Go ahead and try number 26. And number 27. For these, the numerator is odd, so I could just multiply. I'm sorry, I could just raise both sides to the 2 to the power of 2 to cancel that out. But I'll do it the way that I taught you because why confuse people? Don't forget the numerator is the exponent, the denominator is the root. So first thing I'm going to do is take the cube root, which I think will be a safe choice because 64 is a perfect cube. I was about to put 8. My bad. That's 4. All right, and then now we're going to square both sides. And that'll give us n plus 1 equals 16. Subtract 1 from both sides. We get n equals 15. Gross. N equals 15. Right? Yeah. All right, I'm going to double check the answer. All right, 15 plus 1 to the power of 3 over 2 equals 64. 16 to the power of 3 over 2 equals 64. All right, the square root of 16 is 4. So 4 to the third power equals 64, and that is a true statement. Woo, woo, woo. All right, go ahead and try number 28.